Calculate the number of moles of CO2 present in the container after 20 minutes of heating. PV equals nRT. N equals PV/RT equals 1.04 atmospheres, 1.00 liters, / 0.0821 liters atm/ moles K. 1100 Kelvin equals 0.0115 moles CO2. 1 point is earned for the proper setup using the ideal gas law and an answer consistent with the setup. The student claimed that the final pressure in the container in each experiment became constant because all of the CaCO₃ had decomposed. Based on the data in the experiments, do you agree with this claim? Explain. Do not agree with claim. Explanation I. In experiment 1, the moles of CaCO₃ equals 50.0 grams / 100.09 grams per mole equals 0.500 moles CaCO₃. If the reaction had gone to completion, 0.500 moles of CO2 would have been produced. From part A, only 0.0115 moles was produced. Hence, the student's claim was false. Explanation 2. The two different experiments, one with 50.0 grams of CaCO₃ and one with 100.0 grams of CaCO₃, reached the same constant, final pressure of 1.04 atmospheres. Since increasing the amount of reactant did not produce more product, there is no way that all of the CaCO₃ reacted. Instead, an equilibrium condition has been achieved, and there must be some solid CaCO₃ in the container. 1 point is earned for disagreement with the claim and for a correct justification using stoichiometry or a discussion of the creation of an equilibrium condition. After 20 minutes, some CO2 was injected into the container, initially raising the pressure to 1.5 atmospheres. Would the final pressure inside the container be less than, greater than, or equal to 1.04 atmospheres? Explain your reasoning. The final pressure would be equal to 1.04 atmospheres. Equilibrium was reached in both experiments. The equilibrium pressure at this temperature is 1.04 atmospheres. As the reaction shifts toward the reactant, the amount of CO2 in the container will decrease until the pressure returns to 1.04 atmospheres. 1 point is earned for the correct answer with justification. Are there sufficient data obtained in the experiments to determine the value of the equilibrium constant, Kp, for the decomposition of CaCO₃ at 1100 Kelvin? Justify your answer. Yes. For the equilibrium reaction represented by the chemical equation in this problem, at a given temperature, the equilibrium pressure of CO2 determines the equilibrium constant. Since the measured pressure of CO2 is also the equilibrium pressure of CO2, Kp equals PCO2 equals 1.04. Note, if the response in part B indicates yes, that all of the CaCO₃ had decomposed, then the point can be earned by stating that the system did not reach equilibrium in either experiment, and hence the value of Kp cannot be calculated from the data. 1 point is earned for correct explanation that is consistent with the student's answer to part B.